Hi and welcome. This time around I have a project that I've taken directly from Tom Lipton over at Ox Tools. As a matter of fact, Tom was so generous as to make his drawings available to anyone that wanted them. And the project is for a rod bender assembly. It's a pretty neat little project. I don't bend rods all the time, but it's just a fun little project, and every once in a while I do need to make hooks, and I've just sort of done it in the vise sort of crudely, but this is kind of neat. I've seen him bend up to 3/8 inch stock in it. I don't know if it'll go more than that. He didn't seem to have a problem with a 3/8 inch stock. Instead of the pin here, that 3/8 diameter pin that the stock rotates around, he used a 3/4 pin, which is this outside diameter of the base piece. And it seemed to work okay without too much effort on his part. So that's pretty awesome. The materials are pretty easy to come by, and I'm not sure that the dimensions on any of these parts are particularly critical. A neat thing about the design is that the assembly here that does the bending is actually done by a 3/8 inch pin that sticks up there. My initial thought looking at the drawings without watching his video again was that this piece sticking out here did the bending, and I thought, gee, that may not last very long. But that piece actually mates up with the 3/4 diameter of this guy that sticks proud and makes a flush surface. It's actually a really beautiful design. So the part that does the bending is a 3/8 inch pin here, which you can easily replace, and this other pin here you can replace. There is a bronze bushing, so there'll be some cost in buying a piece of bronze there. You might be able to get away with some plastic in there, but it may not last very long with the crushing forces. Let's see what else we've got here. The drawings he gave me are complete and pretty easy to understand. Tom is obviously a master, and he follows that rule that you don't double up on information, which is a standard for drawing design, that you never double up on information on drawing. I tend not to do that because sometimes I want to see a dimension on one representation of a part, and I'd also like to see the same dimension on another representation of the part. But Tom, again, is a professional machinist, so he follows the rules of the trade. And so you can find any dimension you're looking for. You just got to find it on the drawing. It's all there. He did a very, very nice job on them. So thanks again, Tom, over at Ox Tools. And let's just get started. Let's take a look at what stock I've got to make this guy. This guy's roughly 7 inches. Well, it is 7 inches long. This piece right here and this piece right here. This will make it stick out a little bit longer. So fit in a 6-inch vise jaw, no problem. Here's the stock I found for making Tom's rod bending project. And I buy all these as offcuts at my local metal supplier. For me in Southern California, that's Industrial Metal Supply. There aren't a lot of other suppliers down here. There are a couple, but not anywhere near me. But the advantage of buying cutoff is, like this hot rolled 1.5 inch rod, this guy is about 2 feet long, and it's the same price as their pre-cut 1 foot length. So that's a great find. I always buy those when I find them, even if I don't necessarily need them, because I'll use them later. This guy has a really weird proportioned angle iron 1/2 inch thick, which Tom spec'd. It's more than 3 in this direction, obviously a lot more than 3 inches in this direction, but I can cut it down. And the advantage was, instead of paying full price in the artist corner, it's 49 cents a pound for steel plate. So this was fairly inexpensive, and we'll just clean it up. And these are some hot rolled cutoffs. And that should be everything I need to make this project. I am going to have to dimension these. I've spent a fair amount of time dimensioning these, so rather than make you watch all that effort, I'll probably bring you back. One thing to note, though, is that when I'm cutting this angle piece, I have a trick that I learned from someone else's video that I'm going to use. Let me show you what that is. So my first intuition was to take the angle piece, pop it up here with the long part sticking out, and that would go really great until you get to the end. Then I'd be cutting over 4 inches of material, 1/2 inch thick, which, you know, it would cut much more slowly, not just because there's so much more material, but because the tooth pressure, individual tooth pressure, would be spread out over 4 inches instead of 1/2 inch. So even the tooth pressure would go down. And if you increase the tooth pressure, you might overfill the gullets and then cause your blade to break or stick or get damaged. So one of the tricks you can use when you're cutting material like that is to flip it like this so that you have a consistent thickness all the way through. The clamping isn't quite as good, but it's still more than adequate to do the job. So that's what I'll be doing here for this big stuff. All right, so I figured I'd start with the base part first, the part that clamps in the vise, and I've labeled the vise and the top sides. Not that it's really essential, but just to keep me honest. And we're just gonna load this guy in here. And I think, maybe so I can get my 0 and repeat it, let's clean this off. We'll just use my vise stop and come up against it. And I'll set my 0s based on that. And we'll start. First, we're going to drill and tap a couple 3/8 inch holes back here, 3/8 16, and then we've got to remove a 1.5 inch section out of the corner of this where we'll be welding the rotating post on. So that's a later part of the project, but we're going to get this part done and knocked out. I left the sides of this rough sawn because I like the look of it. So what I'm doing, which is how Tom has his drawing made, because that means the dimensions of this aren't critical width-wise, but the way he's got it drawn is everything's based off the center line. So he gives center to center distance here. It does count off this edge, which I did mill to be flat, but the sides are left off, which means they're sort of rough to calculate distance based on. So we're using the center line instead, which makes it pretty straightforward, and that's where we're at. So it's plus or minus 2.25 either side. Alrighty. So that's those two guys. Next, the design shows nipping a 1.5 inch diameter hole where the center is offset by 0.54 off the side, 0.25 up from the bottom, and that's where we're set right now. Well, I gotta tell you, this is only cold rolled or hot rolled steel, but it's cutting through it like butter, this cutter. And that's all there was to it. That was pretty trivial. So that's it for this piece. That's a really nice cut. I just got to deburr a little bit, not even much of a burr. One mistake people make with annual cutters that I've read about, at least on the internet, is people running them too fast. Got to run them slow, or you, especially the high-speed steel ones, you can burn up the edges because they are very fine, a very sharp edge on the inside with a very small amount of material, so it can heat up easily and you can damage it. Next up, we're going to make the plate that the rod lies against that supports it for bending. It gets bent around a mandrel. This is just the piece that prevents it from going this way as you're trying to bend it down here. By the way, when I divided 5.5 by 2, I came with 2.25, and I'm probably the first person on the planet to do that. Should have been 2.75. He has the slots most closer to the edge. I'm not going to worry about that. I'm just going to maintain the 2.25 so I don't have to remake the part. It really isn't a big deal. So we're just going to do that right now. And what I'm going to do is I'm going to drill a few holes. They want ½ inch in, and then up to 1.5 from the edge, and I'm just going to punch a bunch of holes with the drill before I go to the end mill. This is a 3/8 inch mill drill bit. And I've got the mill slowed down. This is just mild steel. And he actually has you mill the slot out to 0.41. I'm not quite sure why so wide. That's about 26 thousandths over. I'm not sure how he came to that, arrived at that value, but I'm going to follow it anyways, because I'm so careful to follow everything else. All right, so the next hole is up 1. So we're going to 1.5. I'm actually going just shy of it by 10 thousandths so I can walk up to and get a nice clean slot. That's deflecting. I'm going to do that with the end mill. I'm not happy about how much the drill bit deflects or the chuck. So we're going to come back and follow that up with an end mill. So we're just going to use a 3/8 inch end mill here and nibble at the sides of this slot. All right, so here are both slots, and you can still see a little gink on both sides where the drill bit deflected. That's kind of sad. Learned my lesson there. Don't do that again. Instead, just nibble away with the end mill. Works great. This is a 4-flute 3/8 inch end mill. Had really good luck with it. The next part is the center pin, which is sort of the mandrel which the stock is bent around. And I noticed in one of Tom Lipton's recent videos, he used a straight 3/4 inch piece of material rather than the smaller 3/8 or just slightly over 3/8. But these are replaceable pins, so I'm going to make one of each. I just got some 3/4 inch 4340 stock, and which is really strong alloy steel, and I'm going to use that. It's not hard. I think it's in a pre-hardened state. I'll take a look at the Rockwell hardness on it. It would be nice if it was in the Rockwell 20s or 30s at least, because that would make it stronger rather than completely annealed. So first I'm just going to do a 3/4 inch piece, full diameter. That's some seriously hard material. I'm going to go check it on the Rockwell. I checked this sample and it's Rockwell C about 17. Not as hard as I thought it was. This alloy steel really cuts with some difficulty. Now I'm just going to make the .380 center version. I did the full 3/4. We're going to do another 100,000th depth of cut pass. This is very hard material. This the feed rate is like only a couple thousandths of revolution, 3.5. I probably need a faster feed rate. Still getting a little bit of chatter. Great surface finish. Light passes. Light passes don't leave a very good surface finish on this material. 50 thousandths depth of cut leaves a mirror finish. This is a 18 thousandths depth of cut, and it's nowhere near as nice. And that's it. There's my mandrels, the 3 of them. .380 as Tom spec'd, a .750 like he did for his latest bending. I guess this controls the radius, and this is just a spare because I did my Rockwell hardness on that one.